Hi, my name is Cody Van Gosen. Today I'm going to be presenting on topics 29 and 30. We're going to begin with topic 29, which is non-probability sampling and qualitative research. For non-probability sampling, there's some distinct differences and comparisons to be made with regular probability samples as opposed to non-probability samples. Probability samples have a random selection, and each member of the possible selection or of a population has an equal possibility of being selected, which is the really paramount difference between probability and non-probability. In non-probability samples, this possibility of selection is not equal, which then instead will place a focus on more of like the group being studied as opposed to being able to generalize the findings of a study as in a probability sample where you can take those findings from your sample and more generalize them to a larger group, since your more random population is kind of more representative of a larger population. And then on the other side of this, a probability sample a lot of times can perform more statistical analysis using like a quantitative research method or quantitative data. Whereas a lot of non-probability samples, a lot of times you can have more like a qualitative analysis that could occur, since you're focusing on more of non-quantifiable data such as like traits and characteristics of a group, or like their like measured reactions to like some stimuli of some sort. Non-probability sampling in particular can also be done through purposive sampling. This is where the researcher kind of uses their own knowledge of the population they're intending to sample, and you got to keep that in mind, so that allows them to be selective and kind of pick with a purpose who they want to sample to kind of tailor the research or kind of guide their research in the direction they want to. For these three types, the first would be maximum variation sampling, and this examines the biggest and largest amount of variation among a sample of this type, and it really kind of broadens the sample a little more, even though it's not random. So you do have like a broader term of a broader population of people that you're interviewing or whatever type of survey you're conducting. You then also have extreme or deviant case sampling, and this kind of helps you to identify your limits of each of your like distinct categories, because you can sample these outlier or like deviant cases that don't quite fit in with like the trends or majority of these other groups that you've noticed through sampling, or the other groups you've identified that you want to sample. And then homogeneous sampling is where you sample really like-minded individuals, or not necessarily like-minded, but just really similar or like individuals. And this is also from a bigger and more varied population. This is actually the contradictory approach to maximum variation sampling, just because it's more focused specifically to similar characteristics and demographics and other similar traits between individuals that have been sampled. Next, we have theoretical sampling, and this is similar, but because the researcher again gets to use kind of that knowledge of the population they're sampling, but they kind of selectively choose the samples to kind of keep extending or even sometimes revise whatever theory or guiding research principle they have for their study. And this keeps occurring until they get to a point where they feel that for somebody new they keep interviewing, that it doesn't, or interviewers collect data upon, that it doesn't really add much to their already established data. And once they reach this point, they're said to have met saturation, which is just basically when you keep sampling people, but you just don't have like a change in data or like anything really substantial compared to what you've already gained. So you kind of just need to, at that point, you got to assess like, okay, do we stop the sampling here? Is our sample size good enough? Is our sample representative of what we were looking for, and characteristics like that? Another sampling style we have is snowball sampling, and this one's really useful. This sampling style is really useful for sampling populations that are really normally hard to sample. Specifically, a really good one is like drug addicts, criminals, and just other things where, like, it's kind of similar situations like that, to where people don't really have an inclination to go ahead and submit to like a survey or sample about those possibly illegal or amoral uh, kind of like characteristics or hobbies and activities that they all kind of participate in. And so the way snowball sampling works is it's kind of like built into the definition of like picturing a snowball rolling down a hill, is that it starts out really small and then it keeps continuing to build up and up over time. And the really important characteristic with this is a researcher could essentially start snowball sampling just with one participant. And if they can gain the trust of that participant might be able to introduce that researcher to more like-minded or more similar characteristic individuals that participant knows. And so that's kind of where the snowball effect comes in, and it allows it to cascade outwards from like one person to different groups of people. And the main thing with this is, again, you have to have that trustworthiness and kind of ensuring confidentiality of these basically identities and certain like defining or identifying characteristics of these people to make sure that they will feel comfortable in sharing their data with you. And so that's really the most important thing with snowball sampling, to make it kind of work in a manner that'll be beneficial to you. Granted, the issue with this though is you're obviously going to have an inherent bias due to the sample size and the sample selection being so tailored to a very specific type of characteristic. And it's also kind of not really like, it's not random, like a more like traditional probability sampling where you try to have random. So that's why it's considered a non-probability sampling style. Then you also have samples of convenience, and this is just where basically sampling occurs just to somebody that's like in the immediate availability, like due to vicinity reasons, or just they're willing to can be part of a survey just because they're being part of it. And there's like really no research necessarily that goes into who I should select, who I shouldn't select. And it's really just a measure of basically, this picture really does a good job. It's just you're kind of a researcher there, and it's just, this is the people you have right here, and it's convenient, and that's who you're going to sample. A lot of times, if there's not a lot of information about what sampling style was employed for a study, people might assume that this was kind of the measure, and that can kind of lead to like just some obviously bias, and then it kind of brings into question, is this sample representative of anything really? Can we generalize from it? And a lot of times it's really hard to generalize from something when you don't have really like randomness in the background research for determining who and where you're going to be sampling. Next up, we got topic 30, which deals with sampling and demographics. One of the key points in this chapter is understanding just demographics. And these are just background characteristics that really kind of serve as like an identifier for a group, or just an identifier for an individual within a survey or a sample. And these can be characteristics such as like race, age, marital status, gender, and just a lot of that stuff. It's kind of useful because then it allows a researcher to really show that they know more details about a specific individual. And so then can really help in like an analysis and studying and sharing these findings, because then you can represent like different trends among like certain age groups or socioeconomic status, and it allows you to examine those characteristics and kind of think how those different types of variables can play into why your specific sample turned out the way it did. Or in an example of like more of like an experimental setting, you could keep demographics in mind to examine like why certain people reacted a certain way to a treatment that was administered and why others didn't, just based off background characteristics and not necessarily the treatment or other variables that occurred. And you could keep these demographics in mind and help to observe like, and then it helps with like a generalization after that, because then you can apply, if you can have a wide range of demographics covered in your sample, you can apply it to then a larger population a little more easily. Another important characteristic to keep in mind is with any research sample, a lot of times you're going to have research sample dropouts. And the issue with these is they're not really like random dropouts. There's really not a randomness to it. Like there's kind of like a reason or pattern or trend you can observe a lot of times that's causing these people to leave. And so then you have to kind of like break it down of, okay, why are these people staying and completing the sample or remaining part of the sample and completing the research or study, and why are these people leaving? And those are some important comparisons that you're going to have to make, and that's really why you got to really examine these research sample dropouts. And within this, a sampling bias can kind of occur through what's called mortality, which is basically what occurs when a participant chooses to drop out of a study. That would be basically what mortality is. And since this is a non-random kind of phenomenon, it introduces that bias. And so you always kind of need to be aware of bias within your sampling, because if you can eliminate more and more bias, it makes your results more accurate, because the more bias you have, the more it actually influences whatever results you found. And that would be it for this chapter. Thanks for watching my presentation, and see you guys in the next one.